Welcome back to the channel, you Kurd nerds. We've got yet another mock check ride. I know I haven't posted one of these in a while. I've been a little busy. There's been a lot of fly-ins going on. I had to go to the West Gladstone annual fly-in that Aircraft Mechanic and Dirtbag and all them, they put on, and it was an absolute blast up there. Be on the lookout for that video. Then, of course, Oshkosh. I've posted all the content from Oshkosh, but I obviously wasn't going to do any mock check rides during Oshkosh. It's way too much going on at Oshkosh to then come back and start working on the computer, pumping out mock check ride content. Then there was a fly-in to North Fox Island. Be on the lookout for that video. That's an abandoned island way out in the middle of Lake Michigan on the actual Michigan side as opposed to the Wisconsin side. And that was an absolute blast as well. Again, me, Dirtbag, and Aircraft Mechanic, we all went out there and camped on North Fox Island before a big old storm rolled through and kicked us out. And then there was even the Chicago Air and Water Show with a surprising lack of water-based show. There's a lot of airplanes, not a lot of seaplanes, not a lot of boats, but it was still an absolute blast. Got a lot of pictures, got a lot of video from that. So be on the lookout. But let's get into this mock check ride. So this student has been in aviation for about a decade as a flight attendant. So they've been their way around, or they've seen their way around a jet once or twice, right? They've been in training for about a year, and they eventually want to go wide body international. It's awesome. I don't want to go wide body international. I like coming home. I don't really like being in an airplane for hours and hours and hours and hours and hours on end. But if you want to do wide body international, more power to you. They've got about 100 hours in a Cessna 172 Mike model from 1975. Now, this POH has less than 100 pages in it. So there wasn't a whole lot of systems knowledge to dig into other than just general systems knowledge, given that the POH doesn't have a whole lot in it. So to give this a little bit of context, a brand new Cessna 172, its POH is around 400 pages, give or take what equipment is installed in it. The Airbus, its POH or its equivalent document, it's about 6,000 pages. So just keep that in mind if you are currently going through flight training and you're in one of these airplanes with these POHs that, you know, the Cheesecake Factory's menu is bigger than. The documents are going to get a lot bigger, so definitely read through the tiny POH that you've got because it's going to be the last small one that you read. So without further ado, let's get into the mock check ride. I'll ask again, are you okay, before we move on, using with me recording this and using this mock check ride for content creation, whether it be on YouTube, TikTok, Instagram, etc.?
Yes.
Awesome. So I'm assuming you've seen the videos, whether it be on Instagram, YouTube, TikTok, or whatever.
Yeah.
So you know I've got a little bit of a script that we go through. Every check ride is going to have three outcomes, right? You've got satisfactory, unsatisfactory, and incomplete. Satisfactory means that you are consistently within inside the standards. Doesn't necessarily mean that you don't momentarily fall outside the standards. It just means that you know, understand, and consistently maintain the standards throughout your check ride. If you momentarily fall outside the standards, recognize it and apply a prompt and appropriate correction for that deviation. Then we've got unsatisfactory. That's something nobody ever wants to hear on any check ride, stage check, or training event, but I've gotten one, so it's not the end of the world, obviously. But it means that you're consistently outside of the standards. Pilot deviation, danger to the national airspace system, knowledge isn't where it should be, stuff like that. Last one is incomplete. If you want to look up the reasons for an incomplete, you're looking at 6143 Bravo. That's the regulation, and it's things like illness, weather, aircraft airworthiness, ran out of time, stuff like that.
Okay.
All right. Last thing any DP is going to ask before they move any farther forward is, have you read through the ACS and you understand the standards that you're being held to?
Yes, sir.
Awesome. You'd be surprised how many students haven't, but I have noticed with more of these videos that I am making, more and more people are reading the ACS, which is awesome. So what kind of documents are you going to need to bring to your check ride?
I need my government issued ID, my student pilot license, my medical, and my logbook because I'm still a student pilot.
Awesome. Logbook with all the endorsements in the back. If you want to verify that all your endorsements are correct, there's the advisory circular 6165 hotel. Your instructor should have used that to verify that your logbook was correct. But, you know, again, I've been teaching for almost a decade. I make a mistake here and there. So,
Okay.
not a
Noted
good
it.
thing to, or not a bad thing to go and check. Now, before we go on, where are you at in your training? Roughly how many hours? What kind of got you to this point?
I've been training for just over a year, and I have just over 100 hours.
Okay.
And I want to go commercial. I've been working in aviation for 10 years as a flight attendant.
Awesome. Awesome. So end goals, airline pilot?
Yeah, I'm open. I'm open to options like cargo potentially, but yeah.
Awesome. 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 What are you looking forward to flying? 320? Or are you trying to get in the 7.4 before it finally retires?
No, I would love to fly. I would love to fly the wide bodies, go international. So 777s or something like that.
777s, 330, 350s, 380,
Hmm.
the big ones, the big ones.
The big ones.
Well, that's awesome. Good luck. Um, just remember, have fun, stay training. Don't ever get too, big for your britches. I've got 3 type ratings and, teach in the 320, but I still love teaching in the small airplanes and flying small airplanes. So keep your nose in the books is really the big takeaway from what I've experienced talking with airline pilots versus flying with general aviation pilots. Definitely seems like general aviation pilots are in the books more often, given that the airlines have their own special books. So let's dig into your aircraft. We are looking at a Cessna 172 Mike model from 1975. Is that correct?
Yes, that is correct.
Awesome, awesome. Now this one's a pretty teeny tiny POH. These ones are kind of
It
hard for
is.
me to dig a whole lot of questions out of because there's not a whole lot in here. 88 pages
Yeah.
is the whole POH. So what can you tell me about the power plant that's in this aircraft?
I have a Lycoming engine, and it is a 4-cylinder horizontally opposed. It's carbureted, naturally aspirated, it's air cooled,
Okay.
spark ignition.
Okay. Now you're saying spark ignition. Where's that spark coming from?
From the magnetos.
Okay. Is there anything special about those magnetos that might be different from, let's say, like a car?
Well, a car can't operate if I think the magnetos are dependent on the electric system in a car. I don't know too much about a car, to be
Yeah.
honest, but I know you need you're reliant on your electric for the car to be working. But in this case, my magnetos are independent of my alternator.
Awesome.
So, yeah.
Now, Lycoming, how much power is that thing generating?
I have 160 horsepower.
Okay, 100.
It's actually 150 according to POH, but it's been upgraded.
Awesome, awesome. So is it still the same cubic inches that it came with originally, or at least I'm looking at in the POH, or did they up it to like the 360?
Ooh, that's a great question. No, it's the O320.
Okay,
So still a
awesome,
320.
awesome. Now, you saying it's generating 160 horsepower. At what RPM is that going to generate it?
My max RPM's 27.
So 2,700. That's what it's rated for.
2700.
150 horsepower at 2,700 RPM. So let's say we take this airplane up to like Colorado. Am I still going to get that 160 horsepower?
You have less power because of the density altitude.
Exactly, exactly. Is it possible that I'm going to, am I going to expect 2,700 RPM on takeoff?
No, it will
Nope.
perform with less power.
Awesome, awesome. Let's say I take it down to Florida. That's sea level, right? But it's still kind of warm. Let's say it's a nice humid day, 80% humidity. Am I going to get 160 horsepower out of it?
I think if it's really hot out, the heat and the humidity can still affect the performance of the aircraft.
It definitely sure will. But let's say it's winter in Florida, still 80% humidity, but it's like 72 degrees out.
Great question. It's high humidity, nice temperature. sea level.
So
I'm going to say no.
you're
I'm going to say it's going to have the same horsepower. It's going to have my rated horsepower.
so it's not. Remember, our engines don't run on water. Humidity, it's water, right? If I am trying to start a fire and someone keeps spraying it with a water bottle, is that fire going to get very big?
Is the fire going to grow?
Exactly.
Is that what you're asking me?
Yeah, exactly. Right. If I am trying to start a fire, like let's say I'm in my backyard trying to roast marshmallows, but somebody keeps coming over with a garden hose and misting that fire, is it going to get very big?
Oh, no.
No,
It'll
it's
dampen it down.
exactly.
Okay.
That's what humidity is doing inside your engine.
And okay, I see. The air that's going through the carburetor is humid, therefore it affects it. I get that. Okay.
Yeah. So high density, high temperature, and high humidity all provide us negative performance or reduced performance on our engine. And with something, if only 160 horsepower, that could be substantial, right?
Right. Okay. So all three independently can affect performance. Yep. All right.
How much gas does this thing carry?
I can carry 40, but it's 38 usable gallons.
So why is some of it usable and some of it not?
Because there will be some fuel in parts of the engine or parts of the tanks that aren't accessible for use.
Okay. Now, is that usable or is that unusable gas taken into account in your weight and balance? Or do you, let's say if you put 40 gallons in this, you take it all the way up to that 40 gallons. Is that unusable fuel? Does that unusable fuel need to be added to your weight and balance? Or is it already there?
You're carrying it as weight. So it's, as in, is it part of the empty weight?
Yeah.
You're asking me harder questions than you do on other ones.
So here's the thing. People keep watching the videos, so I got to start changing up the questions.
I actually really appreciate that. I think that unusable oil and unusable fuel is part of my empty weight.
Exactly, right? If I can't get it out of the airplane, it's got to be counted as part of the empty weight.
Yes.
Awesome. So let's dig a little bit more into your fuel system. You said it's carbureted, right?
Yes.
Now, what are some of the downsides of that carbureted engine?
It's a risk that I can get carburetor icing.
Carburetor icing is definitely a risk. Now, it depends specifically on your airplane, and I'm not seeing anything specifically about it. Have you ever put the throttle in just a little too fast and noticed that your engine kind of coughed?
No, not yet.
Okay, then forget what I asked. Now, you have a primer, correct?
Yes.
Have you ever driven an old carbureted car?
No.
No? Okay. Why do I use my primer instead of just pumping the throttle on the carburetor? Doesn't pumping the throttle squirt fuel in?
Pumping the throttle will squirt fuel through the carburetor, but when you use the primer, it goes directly from the strainer into the cylinders. So It is a different path that it follows.
Okay. So why do I do that? What's the big deal?
It's pure fuel without air.
Okay.
Is what I'm thinking.
So I'm going to open up Microsoft Paint real quick. And we are going to discuss exactly where that fuel is going. So here's Microsoft Paint. All right. Here's our engine. Here's our cylinders. Right. We're looking at the engine from the back. Up front, there's the propeller. So when we use that primer, what ends up happening is it comes right up here, right? There's a little diverter valve or a little valve right up here on top of the engine, and it squirts the fuel right there. And, our pistons are in there. They connect to our crankshaft.
Okay.
But our carburetor is actually down here.
Mm-hmm.
Okay. So if I just squirt fuel down here, where do you think it's going to go? If it's underneath the engine, going to dribble out, isn't it?
Right, because the engine isn't running, so there's nothing to. Yeah, okay.
Yeah, so it's just going to dribble out. And where's it going to dribble to? Inside your cowling, right?
Mm-hmm.
So
Okay.
the dangerous thing is you also have your exhaust that runs right about here. All right. I made it red because it's hot. What do you think is going to happen if this fuel dribbles out of your carburetor onto your hot exhaust because someone else just flew this airplane?
Gonna light on fire.
It sure is. That's why we use the primer and we don't just pump the throttle.
Okay.
Really important. I'm not sure if a DP is ever going to ask that, but you hear about Pipers and Cessnas and whatnot burning themselves down every year because people don't want to use the sticky primer. Because over years the primer just gets sticky.
Mm-hmm.
All right. Now, what can you tell me about the electrical system in this aircraft?
I have an alternator with 14 volts of direct current that's engine driven that charges the 12 volt battery, provides power to my buses.
Okay. Awesome. Yeah. So it's providing power to your buses. Let's say you lost your alternator. What are you going to do? You're just cruising along.
My alternator completely.
Well, you're just cruising along, and then you look up on your annunciator, and your volts light popped on, and then you look over at your ammeter, and it's showing a negative discharge.
I think I'd check to see if my alternator circuit breakers popped out, and I'd also toggle the alternator switch just to check. Maybe the alternator belt is still there; it could still work. I could do a reset on the circuit breaker. So that'd be my first course of action.
Okay, so you pressed the circuit breaker in, you turned your alternator back on. It ran for about 3 or 4 minutes. Circuit breaker popped back out. What are you going to do? Are you going to push it back in?
Absolutely not.
Absolutely not.
That's a fire risk.
Exactly. A little bit more on your electrical system. You brought up your magnetos, right? We know that our magnetos, they're separate from our electrical system. And that's why our engine really keeps running, right? If our magnetos required power from the battery or the alternator, once our alternator dies, it's very likely our engine might only have 20, 30, 40 minutes left, which is a terrifying thought, which is why we don't have those kind of electrical systems, right?
Yeah.
So when you go to do your run-up and you're turning that key, what are you doing to those magnetos?
When you turn the key, it gets the starter going, which is connected. Is that what you mean?
Let me rephrase it. When you go to do your run-up.
Okay.
Yep. When you go to do your run-up and you're doing
the key to do. Oh, okay. You do your run-up and you're checking your mags. What's the question exactly?
Yeah. So what are you actually doing to those magnetos when you turn the key to the left? What are you doing to the left magneto or the right magneto when you turn that key to the left one?
Grounding it.
You are grounding it. Which one are you grounding it when you point it to the left magneto?
This is something I actually just learned. But now I'm doubting whether I memorized it correctly. I think the right one, when you turn it to the left, the right one's grounded. You're seeing if the left one can operate on its own independently.
That is exactly it. Awesome. Really good understanding of your electrical system. I dug pretty far trying to find issues, and I couldn't find any. So good job. All right.
Thank you.
When it comes to the rest of your electrical system, there's not really a whole lot going on. What flight control are you going to lose if you have a complete electrical failure?
If you mean by flight control, I'm going to lose my flaps.
That's one of them, or that is it, right?
Okay.
Perfect. Now, what kind of flight, or would that be a primary or a secondary flight control?
Flaps are secondary. Ailerons or it's secondary.
It is a secondary flight control. Perfect. Now, back to that thought, right? We lost our alternator. Battery's completely dead now. Lost your alternator. Battery's still running. You're about 30 minutes away from your home airport, but there's also an airport like 2 minutes away. Where are you going?
Okay, lost my alternator. Still have battery power. I'm 30 minutes from home airport. my battery could last 30 minutes. Where am I going? Does the airport 2 minutes away have services?
Sure. You see the little tick marks next to it, but
I'm a newer pilot, so I would make the more conservative decision and just land 2 minutes away, get it checked out.
not a bad idea. Services at some airports can be a little limited, but probably not a bad idea, right? You don't know what's going on at home. You don't know if you really, really need your radios, especially if your home airport's like a Charlie or what have you. You know, you could lose your mode C, stuff like that. Awesome. Systems. Given that there's not a very deep systems section of your POH, I'm pretty happy with that. Let's get into some emergency procedures. Now, your POH doesn't specifically call out memory items. I'm not sure if you've got a checklist that calls out memory items. But when we do ask, you know, hey, what are you going to do in the event of this failure, in the event of this emergency? If it's an immediate danger, some memory items, things like immediate action items, I need to do this without referencing a document. That's what we're expecting. But if I've got time, if I'm not going to die immediately, if I don't do something, I'm going to reference the checklist is an appropriate response. Got it?
I have a checklist that's designed for my aircraft. I should have maybe sent that to you.
No, you're fine. The POH usually works. So what are we going to do if we have an engine failure immediately after takeoff, after a short field effort?
Engine failure immediately after takeoff?
Less than 500 feet.
I'm trained fly field flow, so fly the plane first. So I'm going to trim for best glide. I'm going to hopefully have a field in front of me that I can put it down. It's going to be 30 degrees off the nose. And then I'm going to follow my flow and shut it down. So I've got my mixture cut fuel off. I'm going to leave my master on for flaps. Pop the doors, make sure my seatbelt's fastened. Hopefully I can do all that in 500 feet.
It happens quick. I've had an engine failure at 80 feet. Whoa. So 500 feet, it'll still happen quick, but you'll probably be able to get all that done, especially with how well you got that out. I definitely see that you could probably accomplish that in 500 feet. I like to practice kind of stuff like that with my students where we set like a fake floor where I'm like, hey, 2,500 feet, 2,500 MSL is our floor. Let's pretend a short field takeoff. Oh no, your engine died. Let's see what we can do. See if we can get it all done before we hit the dirt. Because it lets them figure out like, okay, how much time do I actually have to do these things? Now, what airspeed are you going to maintain if you had an engine failure at 500 feet after a short field effort?
Okay, so 75 is my best glide, so that'll give me the greatest forward distance. But in this case, if the field's there and I just need the time to get everything done, I could do my minimum sink speed, which is 70. But I've been trained to just follow the best glide, which is 75.
Okay. I'm just referencing your POH. It says flaps down 70 is the speed that you're going to aim for. That's why I was kept bringing up that short field effort, because short field effort, how much do we take off with flaps? Or I just answered it. On a short field effort, we take off with about 10 degrees of flaps, right?
Short field takeoffs?
Yeah, you don't use 10 degrees of flaps on short fields? No? Oh.
No.
Okay.
I do that for soft field takeoffs. Short field, we just do brake set full power.
I guess with 150 or 160 horsepower, I could definitely see not wanting flaps for short field. They are draggy. All right. You're good. You're good. Different teaching method. I don't want to say teaching methods. Different decisions. Different ideology around operating with for short field versus soft field versus normal.
Okay.
I have buddies that in 172s they use 10 degrees of flaps on short field efforts, and as soon as they on short field efforts, I have some that they take off with no flaps until they get up to almost takeoff speed, then they drop 10, and there's others that they don't use any for short field.
In a 172 or those different airplanes?
They are all in. It's either 172 or a 150, 152s. So.
Okay.
All right. Now, what are you going to do if you end up with an engine fire during your start?
Engine fire during my start. I'm going to crank it to run the fire through to burn out all the fuel.
Anything else? Let's say the fire doesn't stop, right? You keep cranking and the fire just won't go out.
I need to pull the mixture back and do full throttle forward.
Perfect. Now the fire went out. What are you going to do?
The fire's out.
Mm-hmm.
Shut it down. Fuel off. I've already pulled the mixture out. Ignition off, master off, get out of the plane with the fire extinguisher just in case it comes back.
Perfect. I just wanted to make sure you weren't going to go take off.
Oh. Okay. Yeah. Nope.
People are like, the fire went out. No problem, right? Problem solved. No, obviously not. Now we brought up carburetor icing. How would you identify carburetor icing?
Carburetor icing, how would I identify it? I would have a drop in RPM.
Now, is this going to be a snap? I lost 500 RPM. Oh my God, I'm going to die. Or is it going to be a gradual buildup of loss of RPM?
Great question. No one's asked me that before. I believe because the ice is building, the RPM will be slowly dropping off.
It's going to be a slow drop off of RPM. Perfect. It gets a little insidious because you'll be cruising along on your cross country or whatnot, and you'll look over and be like, why is my RPM 100 low? Let me fix that. And then you'll keep cruising along and you're like, why is this engine running like shit? Maybe it's too rich. Let me lean it out a little bit.
Or sometimes I wonder if the throttle wasn't tight enough and then it snuck out or in. So I fix it thinking that it's just that, but it could be. That's a great point.
Yep. And then all of a sudden the engine doesn't want to run very well. And you're like, oh my God. Then you look at if you have a carb heat sensor or a carb temperature sensor, you pull your carb heat on and the engine starts to run. Well, I'll ask you, is the engine going to run worse or better immediately when you apply carb heat?
Worse.
Right. Do you understand why?
The ice is melting in the carburetor. So it's then feeding water into your engine. So until that water clears, it'll run rough.
Yep. Now, how long are you going to leave the carb heat on?
You want to leave it on a good while, and then I would, as a pilot, just leave it on until I land. And I think if I had carburetor icing, it might make me feel inspired to land just sooner than later.
Yeah. Yep. Would you ever use partial carburetor heat?
Partial carb heat. No,
not unless you have a way to measure the temperature inside your carburetor. Some people do have little gauges that will tell them how hot their carburetor is. Where's that heat coming from?
From my exhaust shroud.
Yeah, it is definitely coming from your exhaust shroud. What else is heated from your exhaust shroud?
My cabin heat.
It sure is. Is there anything I got to worry about with heating my airplane from my exhaust shroud?
Carbon monoxide poisoning.
How would you identify carbon monoxide poisoning?
These human factors. You could be lightheaded. Someone could complain of feeling like a headache, lightheaded. I really need to memorize the difference between hypoxia and carbon monoxide. Do you get sleepy when you have carbon monoxide poisoning?
Carbon monoxide poisoning is a type of hypoxia.
Okay.
All right. Do you know which type of hypoxia it is?
No wonder. Hypemic hypoxia.
It is hypemic hypoxia. So that gets a lot of people because they're like, oh, well, they're two different things. No, they're the exact same thing. There are different things that can cause hypemic hypoxia, but carbon monoxide is one of the things that can cause hypemic hypoxia. So it's all the same symptoms.
Okay. So sleepy, headache, dizzy, the blue fingers.
Mm-hmm. blue fingers, blue lips. What I like to do is try the pudding test. Just say the word pudding, and if you giggle, you're probably hypoxic. Right?
So euphoria.
Yep.
Okay.
And now, what would you do if you all of a sudden notice, like you did the pudding test, and you're like pudding, and you're like, oh shit, what are you gonna do now?
Okay. In this case, I'm wondering what's causing the hypoxia. If I suspect it could be hypemic hypoxia because my heat is on or being caused by carbon monoxide, then I would close the heat and open the windows.
Close the heat, open the windows. You could even open the little vents up near the windows. Yep.
Yeah.
Those are perfect. What you could also do is descend.
Descend, yeah.
Yep. All right, perfect. Couple more emergencies, and then we'll go on to some limitations of this aircraft. What are you gonna do? Let's say we're cruising along on our cross country, and it starts to rain, and you're like, this visibility looks like 6 or 7 miles. I should be good. And airplane's not made out of sugar. It's not gonna melt in the rain. And you keep pushing on. You keep pushing on, and then all of a sudden you're over here asking yourself, is this VFR? Then you look down and realize you can't see the ground. What are you gonna do?
Turn around. Well, note my heading. Do standard rate turn and turn around.
Awesome.
180 back where I came from.
Now, let's say you turned around, you flew back where you came from for about a minute or two, and you still can't see nothing. Looks like you got closed in behind you. What's your plan now?
I would be making a radio call. And you either descend or ascend. Okay. Is what they say in the literature, but it's hard to know which one, because descending you have CFIT as a risk, and then ascending, who knows when the clouds end.
So now, what I'm reading in your POH when you're referencing that kind of emergency letdown through clouds, it specifically talks about a radio clearance to do so. I wouldn't ever change altitude in IFR conditions without talking to somebody, unless you'll learn about it when you get to IFR. But stay put. Turn around.
The radio call.
Yep. Who are you going to talk to? Who are you going to call other than the Ghostbusters?
Flight service. They have the weather, or the nearest airport, or the ATC, the nearest ATC.
Yep, the nearest ARTCC. Do you have any GPS ARTCC. In your aircraft?
We do.
Okay. So what kind of GPS is it?
It's a Garmin 355.
Okay. So have you ever used that nearest function on it?
Yes.
Okay. So if you hit nearest and you hit next page, you'll eventually get to what looks like kind of an antenna that says ARTCC. And that is yeah. Read through the manuals for these GPSs. They are mint. All right. They are really nice. And what you could do is you could just tap that radio frequency, and it will load it into your standby.
Nice.
And then you can push the transfer, and you'll now be with your nearest. Do you know what ARTCC stands for? Air Route
Traffic Control Center.
Air Radar Traffic Control Center. The radar is what you're looking for, right? Because if you just go nearest tower, they might not have a radar, right? If you just go nearest airport, nearest frequency, they might not have an airport, or they might not have a radar. They can't see you, okay? But if you go to the nearest function, I don't remember if the 355 has a dial or if it's only touchscreen. But if you scroll through it, you'll eventually find the nearest ARTCC. And they are going to be the people you want to talk to. 121.5 is also a good option. Somebody will talk to you. Okay.
Okay.
Now, what's that radio call going to sound like?
My radio call would be who I'm calling, and then this is Cessna 5201 Hotel. with my approximate location, with my altitude, and that I'm in the clouds and I'm VFR rated. I'm a VFR rated pilot, not IFR rated. I'm in the clouds and I need help getting out of the clouds.
Awesome. You don't even necessarily need to give them all that information. You can just be like ATC Cessna 123 VFR rated pilot in IFR conditions. I need vectors to the nearest VFR airport. They're then going to give you a squawk code. Have you ever heard of that?
Yes.
Yep.
And I squawk it where I'm usually squawking 1200. So I enter that there.
Yep.
In my transponder.
And they're probably going to say ident as well. Okay. You know where that button is?
Yes, I know where it is.
Awesome. Awesome. Do you know what that does for them?
It makes me show up as a little green dot on their radar screen.
Yeah. You'll either show up a little brighter or sometimes they'll flash, right? Perfect. I had a student out on a solo that they tried to get help. And that I did them dirty because I didn't show them where the ident button was. Yep. So now I want to make sure every student I talk to, where's the ident button? Right there. All right.
Yeah.
Perfect. We talked about inadvertent entry into let's talk about a spin. How do you recover from a spin?
I use the PAIR acronym, so it's I'm having a block. It's ailerons neutral, rudder, opposite rudder. So whichever I've watched your things. So I love this. This is one of the best things I've learned from you is that you want to stomp on the rudder that's resisting you the most. Why can't I think of what P is? Power off because you don't want to add energy to it. So power off, ailerons neutral, opposite rudder, and then elevator down.
Yep, elevator briskly forward. Where are you most likely going to enter a spin?
Where I've noticed from accident reports they happen a lot on the base to final turn. That happens on those.
Yep, the base to final turn.
An uncoordinated turn.
Yep, it happens a lot more often with crosswinds.
Oh, crosswind turns.
Yep. So base to final. No, not crosswind turns. Base to final with a crosswind.
With a crosswind.
Yes.
Oh, okay.
Okay. It's because the student tries to stomp on the rudder to point their nose towards the runway. And then what happens when you stomp on the nose or stomp on the rudder, but don't coordinate with the aileron? You end up
uncoordinated turn. Yeah.
Yep. And then you increase your drag because the side of the airplane's going into the wind. What happens to your descent rate when that happens? It's a slip to land, right?
It increases, yeah.
And then, but a lot of people, they see their descent rate shoot up and they pull. Well, there's your spin. There's your spin entry. Perfect. So far, emergencies, I absolutely love it. Oh, excuse me. Sorry.
Okay.
So far, you're doing great. I haven't ran into anything where I'm like genuinely concerned.
That's good news.
Yeah. Let's get into some limitations. Now, your airplane. Yep, that's good. What is the speed I should never exceed in this aircraft?
My VNE is 184.
Is your aircraft rated in miles per hour or knots?
Oh, yes, it's miles per hour. 184 miles per hour. Is the POH in knots?
No, it's given me them in calibrated.
Oh.
Yeah, the POH is reading them off in calibrated speed as opposed to indicated. And you've probably learned indicated.
Yeah.
Awesome. Now, what is the top of the green arc indicating on your aircraft?
Top, the highest speed. That's my maximum structural cruise speed.
Okay. When can I exceed that?
In very smooth air.
Perfect. Now, what's one of the big airspeeds that aren't on your airspeed indicator? It's not marked anywhere.
That's VA, maneuvering speed.
Okay, so what does maneuvering speed mean to you?
It is a speed at which I can fully deflect one control. Why can't I think of the word? One of my controls, either my ailerons, rudder, or elevator, without major damage to the aircraft.
Without damage to the aircraft. I wouldn't even necessarily say major damage, just without damage to the aircraft, right?
Without damage. Control surface. That's what I was looking for.
Yep. You can make one full abrupt control surface deflection without risking damage to the aircraft. Perfect. I'm happy with that. Is there... Some of this is sideways. You know, I love it when POHs are simple.
Simple feeling.
Now, is there anything, given that, again, how limited in the way of information your POH is there any systems that you're a little concerned about that you have questions about?
I don't think so. I've been to the hangar, seen it with the cowling off, and it is actually a pretty simple system, the airplane itself.
Mm-hmm. Yeah, they're about as simple as old Volkswagen Beetles.
I think I understand what I need to understand to fly it. There's always more to learn, but...
Well, yeah, if you get the opportunity to work on your own airplane, oh my God, the amount that you learn is... Oh, I spent 7 hours working on my airplane yesterday because I saw high EGTs on one cylinder, and it ended up being a blown out intake gasket that I spent 6 hours replacing. Then my mechanic shows up and shows me how I could have done it in 30 minutes.
Oh gosh.
I was but I learned a lot. All right. Let's get into some airworthiness. What is required? What documents are required to be in this aircraft for it to be airworthy?
My plane needs to have AERO, which is the airworthiness certificate, and the registration, and operating limitations, and the weight and balance information data.
Awesome. Now you said that you've got a GPS in this aircraft, right?
Mm-hmm.
Is there any book associated with that GPS on how to work it?
Yes, I have my supplemental manuals also. Those are required for my plane as well because I have that extra equipment.
Yep, they are definitely required. Now, let's say, does your aircraft have that fun little no smoking placard?
No,
it doesn't. All right. What about down next to your flap handle? Is there a little placard that tells you what speeds you can put flaps in at?
I just have the little flap handle.
Oh.
I know I was thinking about placards and markings. Those are required as well. And I'm going to make a note when I'm in my plane next time to make sure I know which ones are markings and which ones are placards.
Yeah. So here, let me see if I can. A lot of times POHs have a placards section. Make sure I didn't miss anything. Painted surfaces, performance, power, principal dimensions. Oh, I did not see anything in the appendix. All right. Now, you said you've been over to the maintenance hangar. You've seen it with the cowling off. Have you ever actually seen the maintenance book as well, like the maintenance logbook?
Yes.
So let's say I gave you a maintenance logbook for an airplane. What are you looking for in that logbook to verify that it is still airworthy?
That the AEDs have been complied with, that it's had its annual. If it's an airplane like mine, which is a rental used for students, I need to make sure it's had its 100-hour. It's ELT checked within the last 12 months. And then it's I'm not doing this in the right order. I almost feel like I need to write it out. Aviates is the acronym. So I said ELT, annual 100 hour. Oh, the altimeter and the transponder need to be checked every 2 years.
Yep.
And I already, go ahead.
No, you go ahead.
Oh, I did mention the airworthiness directives, right?
Yes, you did. Perfect.
Okay. I didn't mention the VOR because I'm not IFR.
Exactly. Now, let's say you said your aircraft is being used as a rental. It's, people are getting instruction in it. So it needs a 100-hour inspection because I'm assuming the school is providing the aircraft with an instructor, correct?
Yes.
Awesome. Now, let's say you go and buy an airplane. Do you need to do a 100-hour inspection on it?
No.
No, right? Now,
it's an annual.
Let's say you and a buddy go buy an airplane and y'all come to an agreement that for every hour of flight, y'all are going to put $100 in a pickle jar in the hangar. For every hour you go fly it, $100 goes in the pickle jar. Does this airplane need a 100-hour?
Wait, we all co-own an airplane?
Mm-hmm. And y'all come to an agreement that for every hour you put on it, you're going to put $100 in a pickle jar.
Is this $100 just to pay for maintenance or something?
Yeah, it's just to pay for maintenance. Y'all aren't taking any money out of the pickle jar. Nobody's taking money out of the pickle jar. Just if you fly it for an hour, put $100 in it. They fly it for an hour, put $100 in it. If something breaks on the airplane, you take money out of the pickle jar. You take it to the mechanic. Say, pretty, please make my airplane work again.
I feel like I think there's a way the FAA could see that as like us renting the plane or something. I don't know. I don't want the FAA to get anyone in trouble. But in my mind, that's like we all own the airplane and we're just saving for maintenance.
So here's the thing. 91409 Bravo is the regulation that actually covers when a 100-hour inspection is required. The only time a 100-hour inspection is required is for two instances. Carriage of passengers for compensation or hire, or it's part of a flight school and the instructor is being provided with the airplane.
Okay. So the scenario you created is not one of those scenarios.
Nope, because no student is renting the airplane with an instructor.
And we're not being paid to passenger people around.
Exactly. Right?
Okay.
Everyone hears the 100-hour is required for if the aircraft is being used for compensation or hire. It's the end of it is for compensation or hire in the carriage of passengers.
Right.
All right.
Okay.
So even if you're renting out an airplane, the aircraft does not need a 100-hour inspection.
Okay.
There's a really good example of this out near me. There's this guy, Duffy. I think he's been around since the dinosaurs. But he buys a bunch of Cessnas and he leases them to people. And then they can do whatever they want with that airplane. They can make it as part of a flight school. They can just fly it for fun. Either way, he leases it to them for a monthly fee. He doesn't have to do 100-hour inspections on these aircraft. Right? But if somebody leases it from him and then they go and use it as part of their flight school, they need to do the 100-hour inspection on it.
Okay.
Now, who's responsible for verifying that an aircraft is in an airworthy condition?
That's kind of a tricky question because I, as the PIC, am responsible for verifying that it is, but ultimately the owner is responsible for keeping it in an airworthy condition.
Yep. So it's the owner or operator that's responsible for keeping an aircraft in an airworthy condition, while the PIC is responsible for verifying that it's been kept in an airworthy condition and to not fly it if it isn't, or at least not fly it if they can't verify it, right?
Right.
So when you go and rent an airplane, are you now the operator and it's your responsibility to maintain it?
When I rent an airplane, I am not the operator.
No, you're not. Perfect.
No.
It is not your job to ever fix somebody else's airplane unless you have an agreement. Okay. Perfect. So let's say you walk up to your airplane and what instrument do I want to pick on today? Let's say your turn coordinator or your rate of turn indicator. It's busted, right? You hit the master switch, and all you hear is what sounds like marbles in the back of your rate of turn indicator. Is this airplane airworthy, or is there any way that you could make it airworthy?
Turn coordinator. So I could write out 8 tomato flames. Based off of what I'm just thinking of in my memory about 8 tomato flames, turn coordinator is not on that list. I'd have to look at 91205 or write it out for you right now to make sure. I'd also reference 91213, which would send me to 91205. For day VFR, my T's are my tachometer, my temperature. No. Anyways, turn coordinator is not one of them. So
Perfect.
I don't believe it's required, but I would have to double check my type certificate data sheet, my ADs, and all that. So a lot of things you have to check before you go fly.
It sure is.
Broken.
Now, let's say we checked all those things, right? 91213, if we just want to run down it, just make sure we got it all. 91213 tells you to go check 91205. It's not part of 8 tomato flames or flaps. We come back to 91213, tells you to check TCDS, STCs, supplemental type certificates, right? You understand what, does your aircraft have any supplemental type certificates?
A supplemental type certificate is for, I have supplemental manuals for my Garmin. A supplemental type certificate, my understanding is that would be for, it's not like if you have an engine replacement or something, it's a big.
It's not just for engine replacements. A supplemental type certificate is the installation of equipment that was not, that does not meet the form, fit, and function of the original equipment.
So I have an STC for the Garmin.
You sure do, right?
Okay.
So we have to check 91213 after 91205, right? We're going to go back to 91213, check our TCDS, our STCs, our KOEL, if applicable, and our airworthiness directives. Are there any airworthiness directives on this aircraft?
I know from spending time in the hangar that they're always doing the seat rails AD on that one.
Awesome, right?
That's the only one I'm aware of.
Okay. That's all I can think of on that one as well. Kind of surprised. Well, there's one other one. There's for a Lycoming engine, you have to inspect the fuel rails every time you touch the fuel rails.
Oh.
Yeah. It's like, wait.
Okay.
Shouldn't I be doing that already?
Yeah.
Now, in this airplane, right? Do you need a landing light? Is a landing light required?
The landing light's not okay. For day VFR, no. For night flights, yes.
Okay. Now let's say, congratulations, you hit the lottery and you went and bought, I don't know, a Cirrus, but the landing light was burnt out and Cirrus wants like $200 for a landing light. And you're like, yeah, no, I spent all my lottery money buying this airplane. I'm not buying a landing light. Is this airplane legal?
You said it's a Cirrus?
Oh, you know what?
Well,
let me rephrase that because I don't know what a KOEL on a Cirrus is, and a Cirrus very likely could require a landing light. Let's just say you went and bought the same exact airplane that you're currently flying. Does it require a landing light?
Well, doesn't it go back to what we were just talking about? I guess I can't just rely on 91205. I also have to consult my kinds of equipment lists, my type certificate, and my STCs and my ADs to make sure that it's not required by any of those documents.
Okay. What does 91205 say about a landing light?
The L, that's landing gear position lights. So it's not required for day VFR. It is required for night lights.
Night VFR, if for hire.
Can you wait 1 second?
Yeah, no problem.
David. What is, okay. Gracias. Sorry.
No, you're fine. Okay. You're fine.
Someone knocked on the door.
You're fine. 91205, it requires a landing light if the aircraft is to be used for hire. So your personal airplane, not required.
Okay.
All right.
Not required.
I know. It seems weird, but landing lights are expensive. Especially the LED ones. They're $240, $400.
Wow.
All right. let's get into a couple more regulations. So congratulations, you just passed your private pilot certificate. Yay. What can you do now that you couldn't do before?
I can now carry passengers.
All right.
And I have a few other privileges. I can fly for charities. I can help with search and rescue. I can demonstrate aircraft and tow. I could tow, but there are certain limitations to the towing and the demonstrating. Did I miss anything? Oh, I could fly for a business as long as that is incidental to the business. I can't receive compensation.
Okay.
There's a limitation.
So you can't receive compensation for the sole purpose of you flying, right? The example I used to tell to students was like, let's say you're the CEO of Nike. They're obviously paying you a salary as the CEO of Nike. So if you flew your airplane to a meeting, technically you're being paid. You're not being paid as a pilot. Is kind of the takeaway. For another example is like police officers, right? They technically don't need a commercial certificate. They're always going to require a commercial certificate, but the fact that they're flying has nothing. They're not being paid as a pilot. They are being paid as a cop who happens to be flying.
Okay.
That makes sense?
I didn't realize there were pilot police officers.
Well, yeah. Have you ever seen the signs that are like, aircraft speed enforced by aircraft? Or not aircraft speed, but, vehicle speed enforced by aircraft?
Oh, okay.
Yeah. Or like what's another one? Have you ever seen on the late night news where they're like trying to find the person that's running away and they got the helicopter with the spotlight?
Yes. Okay.
That's technically a cop operating that helicopter. Yep.
Okay.
So let's say you've got a buddy with some kind of sports ball tickets, right? And they've got a friend. Correction. You've got a buddy with some kind of sports ball ticket, whether it be football, soccer, basketball, etc. But it's in a whole nother state. It's like 2 states over, and they say, "Hey, if you fly me there, I'll give you the spare ticket that I got." Is this legal?
That's a no.
That is a no.
The FAA sees that as compensation.
The FAA sure does see that as compensation. Now, let's say you are going to be flying to, Montana anyway. Right? You're just going to be going that way anyway. And one of your buddies says, "Hey, I've got a meeting there. Can I hop in there with you?"
I'm going anyways.
Mm-hmm.
So we have common purpose and I'm not receiving compensation.
Now you have a common destination.
Common destination.
You have a common purpose.
Oh, I see. Like I'm providing him a ride to something that I'm not attending.
Mm-hmm.
No.
Nope, it's not allowed, right? Because the FAA views the flight time, whether you paid for it or not, as compensation.
Okay.
Right.
I see. Oh, because I receive flight time.
Exactly.
Right.
And you are carrying passengers from point A to point B. The flight time itself is compensation. Congratulations. You are now carrying passengers from point A to point B for compensation.
Okay.
Now, if you're both going there for a common purpose, you both go and get lunch or what have you, and then you guys kind of go and do your own things. Well, you both went there for lunch. It's not their fault. It's not your fault they didn't get back in the airplane. Right? It's not like you got to hog tie them and throw them in the cargo hold and be like, "Nah, you got to come back with."
Nah, they just
Okay. Perfect. Let's get into some airspace. Now, if you were going into a Class D airspace, what would you expect to hear from that tower to verify that you were okay to operate within their airspace?
I need 2-way communication to enter Class Delta. I guess I'm confused what you mean by what would I hear. I don't need to necessarily.
So
they would say my call sign because they're communicating with me. So
exactly,
just the communication back and forth of them saying acknowledging me, saying my call sign, and telling me that I'm able to enter the airspace.
exactly. So if they respond with last calling, stand by, are you all okay into their airspace?
No.
No. Now, if they say last calling, or not last calling, if they say, Cessna 123, Roger, are you okay to enter their airspace?
They acknowledged me and they said my call sign. So yes.
Exactly. Perfect. What kind of weather do you need to be at that airport for it to be okay for you to go there?
I need the 152. So I have to have 3 miles of visibility and then the cloud clearance 152.
Okay. Like your 152 needs to stay clear of clouds, or like?
Oh, I'm sorry. Okay, so I need 3 miles of visibility, and then my cloud clearance, I need 1,000 feet above the clouds. Is it 500 feet below the clouds? And then 2,000 feet laterally?
That's exactly it.
Yeah.
Perfect. Now, let's say you went to this Delta airport, right? You landed, you went and got lunch, had a good old day. You came back to the airplane, you got the weather, ceilings went down to 2,000 feet. It's raining, 2 mile visibility. But somebody just landed and you asked them like, hey, how big is this storm? And they were like, it's not that big. About 3 or 4 miles away, it clears right up. And it's clear for 1,000,000 miles. Are you stuck at this airport now that the ceiling's 2,000 feet with 2 mile visibility? Or is there anything you could do that could make it so you could leave?
If the terrain was such that allowed me to fly lower below that cloud ceiling, like at 1,500 for a few miles to get out of the storm. I mean, would this be advisable? No, but you could ask for a special VFR just to get out of the area.
Yep. So that's it. The special VFR. You could request a special VFR clearance. I thought you were just going to say, yeah, scud run it with 2 mile viz. We'll be good. I'm like, we're about to have a long conversation.
I should have started with the special VFR. If they give you a special VFR and you
obviously, you are right. Like, would this be recommended, especially as a new pilot? No, obviously not. But it's an option. It's not a good option, right? Like eating a bag full of prunes. It's an option, not a very good one.
Oh no.
So let's talk about aerodynamics. What are flaps good for?
Flaps allow me to increase my angle of descent without increasing my speed.
Okay, so how are your flaps doing that? What are they changing to the wing? What are they changing of your airfoil to make it so that you can descend at a greater rate without an increased airspeed?
They take the wing and they change the camber like that.
Okay.
So they'll change the angle of attack, I guess. The angle from the leading edge to the trailing edge.
Right. So they're moving the back of your cord line down.
The cord line.
Yep. They're moving the back of your cord line down, which increases your angle of attack. With the back of your cord line moving down, it's increasing the upper camber on the wing. And a wing with more camber will generate more lift at lower speeds with higher drag.
Okay.
Right. Perfect. Now, what is a stall? Aerodynamically speaking, what is a stall?
A stall is when you have exceeded your angle of attack and you lose lift.
All right. Now, when I stall, is my wing no longer generating any lift? Am I pretty much just a rock falling out of the sky?
No, but the air is not flowing. It's disrupted. It's not flowing over the wings in a way that creates enough lift to keep the plane up, flying.
Perfect. Let's talk about some of the angles on your wings. You've got a Cessna 172 Mike model, so its wing is it's a pretty simple kind of Hershey bar wing, right? But one of the angles on it, right, where the wing root is lower or closer to the ground than the wing tips. What angle is that called?
The wing root. Okay, say that one more time.
So I've got a little archer right here. You see how the wing kind of slopes down right? What angle is that? What is that called?
Now I'm thinking of this term angle of incidence, but I don't think that applies here.
No,
I don't know.
That one is called dihedral. Have you ever heard that term?
Okay. Yes.
Yeah. So
it's like, you see, because the wings kind of go like this instead of
like this, right? Because what would this be?
Okay. I don't know.
Anhedral, right? Kind of like the Antonov or like an F-18, right? Those are a perfect example of anhedral versus dihedral.
Okay.
Why do trainer aircraft have dihedral while, more complex airplanes or more high performance airplanes have anhedral?
A complex airplane, I mean, they want to probably do maneuvers. They want to be more maneuverable to get into some pretty gnarly maneuvers. Trainer airplanes, you want them to be very, very stable and to be less likely to stall.
All right. So what is dihedral doing for me?
It's stalling the wing. Does it change where the stall starts? It does. It makes the wing stall first on the outside.
All right. You're thinking washout?
I'm thinking something different.
Yeah, you're thinking washout.
Washout, which is the twist of the wing.
Yep. Dihedral is it's a stabilizing angle. So if I'm cruising along, in my little Archer, my Cessna, whatever, and I get a little bump of turbulence and my wing just kind of tilts like this wing is now more aligned with the wind. So now it's going to generate more lift to pull my airplane back to center. Right?
Okay.
But if I flip this airplane upside down, right, and now all of a sudden I have anhedral, so when my wing gets disturbed, now this wing is more in line with the relative wind. It's going to generate lift and continue to disturb the aircraft. Right?
For spins and things.
Positively stable, negatively stable.
Okay.
Right?
Got it.
So dihedral is a stabilizing angle that ensures that the aircraft will kind of return to neutral when disturbed.
Okay.
Right. This is why you can kind of let go of the controls on a Cessna and it just kind of like stabilizes itself and it'll just kind of up along all on its own. Right. Perfect. Now we did talk about, or you brought up washout. Washout, it's that little twist, right? It's how right here at the root, right here at where it connects to the airplane is steeper, has a higher angle of incidence than the tip, right? Because we want the stall to propagate from the root out. Why do we want the stall to propagate from the root out? What is that helping with?
Stability.
Yeah, it's helping maintain aileron control into the stall. Okay. The Icon is a perfect example of this. They put so much washout angle in that wing that you cannot dip a wing. The thing will always stall flat unless you're out doing dumb things. But if you're staying within the aircraft's limitations, its washout angle is so steep that you can't stall enough to make the ailerons ineffective.
What's the name of that plane?
Icon A5.
Icon A5. I'm gonna look it up later.
Yeah, it's a seaplane.
Okay.
Okay, it's a $500,000 jet ski with wings.
Wow.
Now, what is adverse yaw and why does it happen?
Adverse yaw occurs when you're in a turn. It's the tendency for the plane when you're turning to turn the other direction.
It's the tendency of the or when I bank for the nose to track outside of the turn.
Yeah, like this wing gets pulled and then the nose gets pulled out.
Okay, so why does that happen?
Drag on this wing. When you bank, this wing will have induced drag.
It'll have more induced drag because it's generating more lift. Exactly. Now, Is there any design features on this aircraft to try and prevent adverse yaw or try to counteract adverse yaw?
I don't know.
There is differential ailerons. You notice how your ailerons, they go up and down, right? So when I bank to the left, the right one goes down, the left one goes up. Well, on most Cessna aircraft, they actually have what's known as a differential aileron, meaning the one that goes up will go up to 20 degrees, while the one that goes down only goes down to 15 degrees. So it's trying to put that other aileron up higher to kind of give you like almost like an air brake to try and counteract the yaw from the other wing.
Okay.
Right. Most of the time it doesn't work too well. That's why we use rudder.
Yeah.
Okay. But talking about rudder, why do I need rudder more during high power situations like takeoffs and climbs?
For the left turning tendencies.
Okay, so what are those?
P factor, which is like asymmetrical with the propeller, and torque. P factor, torque, slipstream that hits the back of the left rudder or empennage, and then I'm missing the last one. I've got P factor, torque, slipstream. There's one more that I'm totally blanking on.
Gyroscopic precession.
Yes, gyroscopic precession.
All right. Can you explain what gyroscopic precession is to me?
The best way for me to understand it is thinking about a bicycle. And when you're riding a bicycle and you go to turn, the turn occurs because of the lean, and then the actual turn happens 90 degrees later. There's like a delay. I don't know if I had to explain that well, but I can picture it in my mind that that's how it works with a bike.
Right. That is how it works with a bike. Now, how does that really apply to an airplane?
Because the propeller, I think gyroscopic, the propeller is a gyro, and its force is felt 90 degrees later, which turns it to the left.
Okay. So when I pitch up, is gyroscopic precession taking me left or right?
When you pitch up, I think.
Which direction is our propeller spinning?
Like this.
Yeah, from the seat.
To the right.
To the right.
Oh, from the seat. It's to the right. So it would actually, when the prop pitches up, it would occur to the right.
Exactly. The reason it's called a left turning tendency is because the book was written back when everything rode around on its tail like this. So when you go to pick the tail up before you take off in a tailwheel airplane, it would yaw you to the left. That's why gyroscopic precession is referred to as a left turning tendency. A lot of people look at it and go, wait a minute. Why is it in that chapter then?
But when you're in a climb attitude,
yep,
it will be a left turning tendency.
Nope. Still, when I'm pitched up, the gyroscopic precession will take me to the right. Right?
Yes.
But P factor is a stronger force.
Which is why we need the right rudder.
Yep.
Okay.
Have you ever noticed that when you pitch the nose down slightly, you need to just give a touch of right rudder? Like when you go into descend without reducing power, you need just a touch of right rudder.
Mm-hmm.
That's gyroscopic precession.
Okay.
Right. Now, let's get into some aeromedical stuff. We talked about hypoxia. We talked specifically about hypemic hypoxia. What are the other types of hypoxia?
This is a weak spot of mine. You found it. Hypoxia. I really need to study up on this. I know there's one called stagnant.
Okay. Can you give me an example of stagnant hypoxia that isn't related to G-forces?
I feel like stagnant hypoxia occurs when the oxygen is cut off. So there would have to be something causing you to the oxygen not flow in your body, like sitting in an airplane maybe for I don't know, for a long time.
That's exactly an example of stagnant hypoxia, right? Have you ever noticed your feet get tingly when you sit down too long?
Mm-hmm. That's stagnant hypoxia. Okay.
Yep. And then when you go to stand up, you get all lightheaded.
That's also stagnant hypoxia. Okay.
Right. Because let's be honest, in our Cessna 172, we're not experiencing enough G forces where stagnant hypoxia should be a concern. But if I've got somebody that, might be a little bit overweight and they end up in a cramped small airplane for a long time, it's likely that they could start to experience that. And you might want to warn your passenger, like, hey, we've been sitting down in a cramped airplane for 4 hours. Be careful standing up. You might get a little lightheaded. Right?
Mm-hmm.
That's really why we care about the different types of hypoxia. It's when are they going to occur? How are they going to impact us and our passengers? Because now we can have passengers.
Yeah, I feel like your examples are so helpful that this is actually what's going to help me finally drive it home into my brain. So we've got stagnant, I've got hypemic, which is the carbon monoxide. Well, carbon monoxide is one way you could become hypemic.
Mm-hmm.
And then I don't have the other ones.
So there's hypoxic and histotoxic. So hypoxic is just lack of O2 or lack of oxygen absorbed by the body due to lack of pressure. All right. This one, I guess not necessarily lack of pressure. You could technically be in a non-oxygen rich environment or something that's rich in something other than oxygen that isn't necessarily binding to your blood cells. But either way, not enough O2. Not enough. Yeah. Altitude is a perfect example of hypoxic hypoxia. Okay. And then there's histotoxic. This just means that your cells and tissues are so damaged that even by the time oxygen gets to them, it can't do anything with it. This is things like smoking, poison, alcohol, heroin.
Hypostistic?
Histotoxic.
Histotoxic. Okay.
Think of histo, like history of smoking, history of alcohol.
Oh, history. Okay.
History of toxic.
Okay.
Okay, so we've got all four: hypoxic, hypemic, stagnant, and histotoxic. Hypoxic, lack of O2 absorbed by the body due to pressure. Hypemic,
altitude.
Inability. Altitude, but hypemic, it's inability of the blood to carry oxygen. See things like CO poisoning. Something else has bound to your red blood cells so that they're not grabbing oxygen when they pass through your lungs. Carbon monoxide poisoning is a perfect example of this. All right.
Okay.
Stagnant. Okay. A lot of people want to go straight to G forces. Let's be honest, we're not experiencing those level of G forces in our tiny little airplanes. But sitting for too long and your feet get tingly is a perfect example. Last one is histotoxic. You can think of this as like a history of toxic behavior. Things like smoking, alcoholism, drug use. All right.
Great.
Now, when is it required for you to start using oxygen in an aircraft?
Am I crew or passenger?
Crew. You're a pilot now. Come on.
Okay. At 12,500 feet, if it's 30 minutes.
Okay.
More than 30 minutes.
Now, when are you required to, when you immediately hit that altitude?
14,000 feet. Everyone has to be on it.
All the crew have to be on it.
All the crew.
Yep. Now, let's say I cruise on up to 13,000 feet. I hang out up there for 26 minutes, and then I pop on down to 11. But now I've got another mountain in front of me, so I need to climb on up to 13,000 feet again. But it's going to take me 20 minutes to cross this mountain. Am I good?
This is a great scenario. I believe it's cumulatively anything over 30 minutes. So you got 42 minutes now between the two in your one flight. I think for safety reasons, I would like to know what the actual regulation is.
So the regulation,
the safe decision would be you need it.
The regulation is cumulative. Okay. So
cumulative.
If your flight, if you exceed 30 minutes above 12.5 on your flight, no matter if it's at one time or if it's broken into sessions above 30, above 12.5, you do need oxygen.
Okay. Got it.
All right. Now, what I've noticed from some of the mock check rides that I've done, and some of the students coming back from their actual check ride, and kind of giving me a little of a recon of what DPEs are digging into. Some of them have really been digging into basic med. So, who is eligible for basic med?
You have to have had a at least a third class medical. I need to memorize this year. Is it 1997? After 1997?
After 2006.
Okay. Basic med after 2006. And then you're eligible.
Yeah. So let's say you went and got your medical, or you went to your, heaven forbid, hopefully this never happens to you. It's a terrible experience. But let's just say you went to go get your medical and it was denied. Can you go to basic med?
You can.
No. Nope. So
you cannot.
You cannot. Your most recent medical certificate must not have been revoked, suspended, withdrawn, and have not had the most recent application for medical certificate denied.
Okay.
Okay. Do you know what the limitations are associated with basic med?
The limitations are, they're changing actually, but based on what I've been taught so far, it's a 6,000 gross weight aircraft. You can't fly anything more than that. You can't fly more than 6 passengers. You have to have your CME checklist, your exam done every 4 years. Did I miss any other limitations?
So it's no more than 5 passengers, no more than 6 seats.
6 including you.
Yep.
Okay, 6 seats, 5 passengers including you.
Exactly. Yep. Can't fly for compensation, no more than 250 knots, not above 18,000 feet.
Okay.
Right. So I can't go off and buy is an Eclipse jet less than 6,000? I think an Eclipse jet is less than 6,000 pounds. But it flies above 18,000 feet, above 250 knots. I guess technically I could buy an Eclipse jet and just keep it below 18 and below 250. But then why do I have an Eclipse jet?
Mm-hmm. Yeah.
So dig into basic med. A lot of people, it's a misconception that people think basic med is for people who can't hold a medical. Basic med is purely the FAA trying to simplify medical evaluations for people who don't want to go to an AME.
Okay.
That's all
go
it's
to your
for.
Family doctor.
Yep. Their words is simplified process, makes it easier for pilots to continue flying, and flexibility allows pilots to use their own physician.
Okay.
It's got nothing to do with your inability to hold a medical. All right. So I'm happy with that. So far, I'd say you're doing great and ready to go. Now we're going to dig into your nav log. Okay. I know you sent me some screenshots and some pictures, and I love the little things you drew out. Actually, do you mind if I put these up on the screen and whatnot?
Not at all.
Awesome. Let me.
Yeah.
So if we look here, you've got your sectionals, which we'll go into Sky Vector, and we'll get these a little bit so we can look around. But then you drew these pictures that kind of give you your route and where you're going to be, and when you're going to be checking frequency, or what the AWOS is and everything at all the different airports that are along your route, the flight service station. This is you even drew different airspace. I absolutely love this. This is a lot. I love that you even have alternates down here. Whoever your instructor is should be proud, because you even have an alternate route if the coast is if the weather's not great.
Yeah.
I have never seen a student do this.
That's so funny.
So good on you. It's a lot.
Okay.
I'm going to be honest. I probably should have done stuff like this when I was a student. But this is this is awesome. You've got your true
Thank you.
course. Looks pretty spot on when it comes to true course. I can grab my E6B, or not my E6B, my CX3 real quick, just to check some of these. Given the rest of what you've been doing, I am pretty sure that your ground speed and everything is good. My only concern is your climb. All right. I see that you've just got it at a true airspeed of 122 the entire route. My concern with doing it that way is obviously you're going to be burning 7 gallons per hour in cruise at 122 knots. Do you burn 7 gallons per hour on your climb?
Okay, so I asked my instructor about this. He's actually an amazing instructor. He's been teaching for 35 years or something. And he's the one that draws those cool diagrams. So for all my cross countries, like I've just modeling after him. Yeah. Every time I've planned a cross country, we've drawn out these diagrams. But I asked him about the climb and the fuel burn because in my POH, it's so archaic. You can't really get a lot of information from this maximum rate of climb data sheet. So I said, what am I burning on my climb? And he said, it evens out between your climb and your descent. So just use the 7 gallons per hour for the whole flight, even your climb and your descent.
Oh, I am so sorry. New Cessnas have another chart in here called your time, fuel, and distance to climb chart. You don't have that. You are fine.
Am I fine? So with my check ride examiner, I'm glad you're asking me about this because I was concerned they were going to grill me about it.
The only reason I bring it up is when there is numbers to calculate on.
Yeah.
You don't, we're looking at your POH right here. This is it. You've got your maximum rate of climb data, which it's got a little bit of information, but it's not great.
It's like, what's this whole 1 gallon of fuel used? Like, how is that? What are they talking about? Because they don't even know how far I've gone. Like the chart is weird to me.
From sea level, fuel used.
Like if you're at sea level and your rate of climb, let's say I'm at 2,000 pounds, me and my check ride examiner. And so we've got a rate of climb of 840. It's warm out that day, so I'm going to take off 20 feet, 40 feet total for the 20 degrees warmer it is. So I'm climbing at 800 feet per minute. 1 gallon of fuel is used, no matter if I climb to 2,000 or 5,000 feet. That's what I don't understand.
I think it's your gallon of fuel used per minute.
Oh, it doesn't say that.
Well, but that would be excessive. Yeah, because that's 60 gallons an hour. That's definitely not right.
So my instructor's advice was use your 7 gallons per hour for climb and descent.
You know what? I'm gonna go with that as well. My only other thought is like if you know what your fuel burn is in a climb, just based on experience.
Oh, okay.
All right. So my airplane in a climb above 3,500, I'm burning 16 gallons an hour. Up to that, I'm burning 14 gallons an hour, just because I'm trying to maintain a specific power setting. And as I climb, I lose power. But so I end up adding more fuel to try and compensate for that. But either way,
okay.
I know that my POH doesn't say that.
Yeah, you know that from experience.
Exactly. So you're fine on what you've got here, given the limitation of your POH. You don't have documentation to reference. Okay, so like the only other thing you could do is, reference your experience. And at 100 hours flying this aircraft, experience isn't necessarily a bad thing to reference. But you don't have a time, fuel, and distance climb chart. Keep that in mind as you move on into other aircraft, though, is that this is an exception. this aircraft is an exception to the rule on a lot more aircraft. I think if you go to like just a 1977 Cessna 172, you have a time, fuel, and distance to climb chart.
Okay.
Okay. So your aircraft is somewhat of an exception.
Okay.
All right. But I absolutely love these. You're showing exactly where you're taking off from, where you plan on landing, where you plan on entering the pattern, which is, like, I'm kind of afraid to even ask more questions on what you're doing for your check ride, or not what you're for your check ride before your cross country planning, because this is above and beyond of what I teach my students.
Okay.
Okay. I'm happy with your route.
That makes me feel ready. Thank you.
Yes. Only thing I'm going to do is we're going to go to Sky Vector and ensure that you know how to read a chart, and then we'll talk about some weather.
That's great.
Unless there's something on your route you wanted to ask me about. Obviously, if you've got questions.
With my alternate, I was like deciding if I wanted to avoid the coastline the further south I got. Oh, I could cut over at Roseburg. So I chose Eugene, but I was initially thinking Roseburg. It's further south.
Okay,
but there's a mountain. So to me, it just looks like the cut over following the highway from Eugene is better than the one from Roseburg. But that was the only thing I was questioning.
Okay, so cut following the highway is versus this elevation right here?
Versus Roseburg, and see the mountains on the west, to the west of Roseburg. Yeah. Right there where your mouse is.
Okay, yeah. I mean, I guess your cruise altitude of 4,500. Yeah, I'd be a little concerned about those. Because you obviously don't want to double back around mountains. So yeah, if you want to take your alternate to, where'd it go?
Right there, I think.
Oh, yep. I was looking right at it. That's a bigger airport too. Like, I mean, Roseburg's just a tiny little, airport. You've got this one with nav aids to even get you there in the event that the visibility starts to drop, because you're taking this alternate because you're concerned about the visibility options.
Really good point.
So yeah, I mean, Eugene would definitely be my option. I guess you do have a bunch of VORs around. You'll be fine. Yeah, if you're worried about the elevation, definitely cut over from the shore along this highway, so you've got a place to land in the event that you've got any problems. And if visibility starts to drop, you have a VOR that'll take you to the field. You know how I know it'll take you to the field? Or I'm going to ask you, how do you know that this VOR will take you to the field versus the other ones?
I see the tiny dot to the left of the longest runway.
Awesome.
That indicates that's where the VOR is.
Awesome, right? Because if we look down at this one, the VOR is off the field.
Mm-hmm.
All right.
Right. These are great observations I didn't see. Thank you.
Of course. What is the big difference between these two airports?
They're both non-towered. The one on the left doesn't have services or a beacon.
Okay, not this one. Right? This one.
Oh, that one.
Versus
no
that
hard
one.
surface.
No hard surface for the intention of landing or taking off.
Mm-hmm.
All right.
Okay.
Now, what airspace is this blue?
Class Delta.
That is Class Delta. We talked about how we can enter Class Delta. What airspace is on the ground here?
That's a extended surface area Class Echo.
Okay. Now,
did I say right?
I mean, I just say it's Echo to the ground, if there's a fancy way of saying it. But how high does that Echo go?
All the way up to 17,999.
Perfect. What's on the ground here? Other than dirt? What airspace?
What's on the ground? It's inside the magenta. It's going to be on the ground. It's Golf.
It is Golf. Up to what altitude?
Up to 699.
Perfect. What does this star mean?
The tower is part-time.
Okay, so what happens to this airspace when this tower closes? What does it become?
It becomes Class Echo.
All the way to the ground?
Wait. The airspace, when the tower closes, it's no longer Class Delta. It will be Golf up to 699 and Echo from 700 up to Class Alpha.
Perfect.
Okay.
Now, what is these little dashed lines right here with the purple barrier?
That indicates the MOA.
Okay. Do I need a clearance to enter this?
No.
Okay. So what do I need to be worried about it? What is a MOA telling me?
Military operations area.
Okay.
I should be concerned about military operations, high velocity aircraft, training, artillery. So it's not advisable to go in without finding out if it's hot, as they say.
Okay. Usually the live munitions are associated with another type of airspace.
Controlled firing area.
Yep. So you've got like controlled firing areas, restricted airspace, prohibited airspace. A MOA does not necessarily indicate that there are going to be live munitions.
Okay.
Okay. What is this?
That's a wildlife refuge.
Okay. Any regulation associated with this?
It's recommended or it's requested that you stay 2,000 feet above, and you just do that to be a nice person.
Yep. Perfect. But remember that if some endangered animal or some even protected animal all of a sudden decides it wants to die because you were flying your airplane too low, you're going to be held accountable. But just be sure that when you do look at wilderness areas, make sure there's no notes associated with them. All right. Because here's a wilderness area up near me. This is called the Apostle Islands. Beautiful place to go camping and whatnot. Bring bear spray. But it also looks like a beautiful place for a seaplane, right?
Mm-hmm.
Nope. Landing or operating aircraft within the islands or waters within a quarter mile of the Apostle Islands National Lake Shore is prohibited.
Oh. It's a lake?
Yeah, this is Lake Michigan. Or Lake, not Michigan. What is this? Superior.
Okay.
All right. So just make sure, just because it's a wilderness area does not necessarily mean that there isn't anything else associated with it that would prohibit your operations of an aircraft nearby.
Okay.
Because I thought the same thing. I was like, it's just a wildlife area. I can still beach there. Nope. Glad I read that before I went there. What airspace is this?
Got it. That's a Class Charlie.
Okay. So if I am flying from, let's say, Selma to, I don't know, this one right here. Is that Fresno? I think it is. Yeah, Fresno Chandler Executive. So I'm flying from Selma to Chandler Executive. What kind of equipment do I need if I'm flying there at 2,000 feet?
2,000 feet. If you're flying there at 2,000 feet, then you will be below the shelf of Class Charlie, the outer shelf.
Okay. What equipment do I need?
Then you'd be in Class Echo. You need, this is another weak area. Thank you. Hypoxia and equipment. Those are my main weak areas. For Class Echo, you do not need anything.
Okay. So I'm going to reference my FAR aim just to make sure that I've got this correct. But if I remember correctly, that operations within the lateral boundaries of Charlie airspace still require a Mode C.
Oh, because you're in the lateral boundary. Okay. I'm also going to reference
equipment, unless otherwise authorized by ATC, having jurisdiction over the Class C airspace. No person may operate an aircraft within a Class C airspace area designated for an airport, unless the aircraft is equipped with 91-215, which is the ATC which is the transponder and altitude reporting requirements. So I am wrong. If you look at 91-130D is your equipment requirements, and 91-130D does not say anything about needing mode C below or within the lateral boundaries. So you were correct initially.
91-130?
Yep, 91-130D is going to be the equipment requirements for Charlie airspace. It doesn't say anything about the requirements within the lateral boundaries of it. Only the requirements within that airspace. So you are correct.
Okay.
Echo, no equipment is required.
Okay.
Perfect. Now, what does these little dots indicate?
Oh. It's a dried up lake bed.
Not necessarily always dry. Okay. Sometimes water.
Okay. A place that sometimes has water and sometimes is dry. Okay.
Yep. Of course, given the current climate and the way it's going, it's probably dry. But maybe dry. You don't want to try to land there and find out.
Yeah.
All right. Because I promise, with your gear dangling down, you're not going to do too well landing on water. Let's see if I can find any other good old gotchas. What is this purple line right here?
The dashed line?
Yep.
That's an isogonic line indicating magnetic variation.
Okay, perfect. What is magnetic variation for? What is it?
To help us adjust our heading to compensate for the difference between true and polar north.
True and true polar, true magnetic.
True magnetic.
What is this? This purple line with all the dots?
The ADIS.
It is the ADIS. You know how you can cross an ADIS? Or do I need to do anything?
Flight plan.
Go ahead.
You need a flight plan.
Yep. What kind of flight plan?
And you need to have a certain equipment. You have to have filed international flight plan.
A DVFR flight plan is what it's referred to as. What's going to happen if I just kind of screw up and I accidentally come over this, the ADIS and kind of come on here down into Mexico and I go, oh, I can't read the street signs down here. I must have made a wrong turn at Albuquerque, and you turn back around and you cross the ADIS without talking to anybody. What's going to happen?
Well, is Mexico, I was curious, is Mexico alarmed? Are they sending anybody after you, or are they just more relaxed about it?
To be honest, I'm not sure.
Yeah. So I know that they're not going to be relaxed in the United States. You come across that border and they're going to be asking, who are you? You don't have a flight plan. We don't know who you are. So what's your question?
Yeah. So what's going to happen? Like you're saying they're going to talk to you. Let's say I got my Bluetooth on. I'm just jamming to Katy Perry or something, California girls, right? What's going to happen? What am I going to start seeing out my window?
Military planes.
Okay. So I'm going to start getting interdicted, right?
Okay. Mm-hmm.
So what does an interdiction look like?
They come up on your side and they communicate with you.
Okay.
They train, but my instructors never taught me how to communicate.
Well, it's really important because if an F-16 all of a sudden shows up and he's just waving at you and you're like, oh, well, hi. Right. So first contact, what they're going to do is they're going to pull up on the side in the direction they want you to go. Right. They're going to try to get a hold of you on 121.5, and then they're going to go the way they're going to rock their wings, and then they're going to fly where they want you to go. And you better follow them because they're going to come do it again a second time. And this time with flares, and there is no third try.
Okay, so if I had military flight personnel come up on my side, I just want to make sure I get on the emergency frequency.
Yep, get on 121.5, be like, hey, what's up? But also, let's say your radio failed. Okay,
They're going to rock their wings. You're going to follow them where they go. If you still don't follow them, they're going to come and do it again with flares. There is no third try.
Okay.
All right. So just keep that in mind. If you want to start doing international flying, like going down to Mexico and whatnot, I think AOPA has a course, or there's an FAA Wings course on it as well.
Oh, cool. That's exciting.
So, because there's a lot that goes into it. If you're on an IFR flight plan, it's not that big of it's not as big of a deal. But if doing it VFR is a little bit more complicated.
Okay.
Given that we're only on private pilot and not IFR, right? So I'm happy with your with sectional usage. Let's talk about weather. What are the 3 things I need for a thunderstorm?
Moisture, unstable lapse rate, and rising air.
Lifting force, right? Rising air.
Lifting force.
Yeah. Could be oreographic, could be frontal, could be, heating of the ground, right? Well, when am I going to experience the most severe downdrafts associated with a thunderstorm?
During its dissipating phase.
During its dissipating phase. What are the other phases of a thunderstorm?
Cumulus, where it's building, mature, and then dissipating.
How do I know the mature stage has started?
You'll have, that's where you'll see all of the major weather that's associated with thunderstorms. So lightning, thunder, really heavy rains.
Mm-hmm. A really good indication of mature stage, at the very least starting, rain hit the ground.
Oh, okay.
Yep. Rain, actual liquid water has hit the ground. Now, what are the different kinds of icing?
Do you want to know about the three different types of ice, or the like structural versus induction icing?
So I've got structural, induction. But then I also have I have a couple different kinds of structural icing, right?
Mm-hmm.
So what are those different kinds of structural icing?
Structural icing can occur on the wings. Okay, I need to read about this too.
All right. So we've got clear and rime, right?
Oh, that's what you're asking.
Yeah,
the kinds of ice. Yeah, clear,
kinds of
rime,
icing.
and mixed.
Clear, rime, and mixed, right?
Okay.
Sorry, I probably could have worded that question a little better. Now,
okay, clear, rime, and mixed.
How does clear ice form?
Clear ice forms when you have when the water hits the surface and moves quickly over it.
Okay. Now, is this just any water? I'm gonna go throw some water on my airplane and see if some clear ice forms. No, right? So we need super cooled liquid water droplets. Do we know what you understand what super cooled liquid water droplets mean?
That sounds like a cool band name.
You're up, right?
Super cooled liquid water droplets.
Yep. So super cooled liquid water droplets. Super cooled means that it is at a temperature below its freezing temperature. It just doesn't have a nucleus to freeze to. So water can't freeze without some kind of particulate to freeze to.
Okay.
That's why when it hits your wing, it then spreads back and freezes, because your wing has now become the freezing nuclei.
Okay.
Okay. The only limiting temperature for ice is -40 degrees. All right. So if it's below -40, you can't get ice because it's already frozen. We're not going to be operating in temperatures below. You're not going to be operating in temperatures that low, but it really just tells you anything below. Don't quote me on these numbers, but I think anything below 50, you can start experiencing icing.
Mm-hmm.
Okay. Now let's start digging into some charts. Now, if anybody ever tries to show you this chart without the key, tell them to give you the key. Okay. So what am I expecting to
I don't like that one. Maybe something over here. No. All right. What is the freezing level in Texas today?
16,000 feet.
It is 16,000 feet. Perfect. This chart is not really a whole lot going on. It's really just that. It's big, significant weather. Okay.
Okay.
Not really a whole lot else going on that one. Let's look at this one. A lot of students look at this chart and get a little intimidated because it is kind of showing them a lot and it's a big area, right? What kind of weather would I associate with this low pressure cold front?
Really bad weather. So low pressure is associated with rain and
Rain, showers, possibly thunderstorms.
Lots of clouds. Yeah, it could be thunderstorms. Could be instability.
Right. What is this brown line indicating right here?
I don't know.
That's a trough. It's a line of low pressure.
Oh, a trough.
Yep.
A line of low pressure. Okay, but I don't see any of the little L's near it.
So we've got this L. It's following out from this L.
Oh, okay.
Right. We could see 1004 on this isobar. Oh, I just gave you the answer to that question. Then I've got 1003, I think, on this isobar. And then it looks like, where's this one going to? I can't follow that one. That's all it's showing. So I've got a bunch of isobars that are really close together somewhere. Like right here, right? These isobars are kind of close together. These ones are really far apart. What am I expecting to see here where they're really close together versus over here?
Where the isobars are farther apart, it also looks like there's higher pressure there. You're going to have less wind. And where the isobars are closer together, the pressure gradient is steeper and there's higher winds.
Perfect. Now I've got two different reports here, right? I've got METARs and PIREPs. Which one of these is probably more accurate?
PIREPs.
Definitely PIREPs. Remember, you can file PIREPs. I know a lot of students are a little worried about it. Let's try it, right? Let's look here. What's this Cessna 172 saying in their PIREP?
Can you move it over just a little too? It's hard. I don't know if your screen's inverted. I can only see the time. I can see time. The time is 23:38. And maybe because I'm on my phone, I'm so sorry.
No, you're fine. That is what it is. Let me see what I can do.
UA. Okay.
Is that any better?
No, it was actually better before. Okay.
Oh, where'd it go? I lost it. It was just a funny one because the Cessna 172 said they could see the Atlantic.
Oh, that's funny.
That was the whole PIREP. Was pilot says they can see the Atlantic.
I want to read it.
It's. Let me see. It's if you type in KPI on like your iPad for when you're looking up PIREPs, 1, 2, 3, 4, 5. It's the sixth one down. It just says a Cessna 172 at 900 feet. Sky clear. Pilot can see the Atlantic.
Sky clear. RM. What does RM mean?
Remark.
Pilot can see the Atlantic. Remark. Pilot can see the Atlantic. That's funny.
So file PIREPs. Don't ever be worried about them. Hey, here's another Cessna 172 saying weather clear, turbulence smooth.
Sky clear. Weather 10?
10 out of 10.
10 out of 10. Oh, yep. Okay.
I think that's what that one's showing. Or maybe it's 1,000 feet. I'd have to look that one up.
Or we could just click this little decoded button. Where'd it go? Pilot can see the Atlantic. It's funny. Yeah, I don't know what it's referring to. All right, let's go check out some. Well, can you see these? Or is it really
I'm looking at Pyreps.
All right.
I'm looking at Pyreps on my iPad too, just to check it out. If you want me, I could pull it up here.
No, so what I'm actually going to ask is, you look at the TAF or KPI.
KPIE.
Yep.
Look at the TAF. TAF data, KPI. Okay.
Is there any weather that you'd be concerned about at this airport?
Let's see. Right now, I'm seeing 6 knots from 100. Got good visibility, a few clouds. My broken layer is high. It looks like it's changing, so it's gonna change. I'm sorry. Let me just scan it and I'll let you know if I see anything concerning. It looks like as time goes by, the conditions are changing. There's going to be vicinity showers. The cloud layer. Cloud layer is staying still pretty scattered and high, except then you have a 30% probability between 5 and 21 Zulu of thunderstorms and rain and cumulonimbus, which you would absolutely find concerning.
Perfect. So far I am, I say you're pretty spot on. We talked about a couple things, but other than that, I mean, you recognize the things that you needed to study. Trying to think of what they were right off the top of my head.
Hypoxia, equipment, structural icing, basic med.
That's it.
You got it written down.
But other than that, I mean, those are just little things that are easy to go and brush yourself up on. So I'd say, go brush up on those things, and you are check ride ready. Can you read this winds and temps that I just highlighted, or no?
Yeah, I can see all 6 digits. So 74. Oh, this is that tricky one where it's like minus 50 at 100 or something like that. 34 is my temperature. That's going to be negative 34.
Yes, it is. So you explained how
74 cannot be a wind direction. So it has to be 360 or less. Is it 240 minus 50? So 240 wind direction.
I don't know. I'm asking you. Yes, it is 240.
Okay. I know. 240 wind direction, and then that's wind direction. Then my wind velocity, it's at 100, so 102 knots.
It sure is 240 at 100 knot or 102 knots. Perfect.
Can I ask you why they do that?
Well, because these used to come out on. You ever seen some old timey movie where they're talking about stocks, and it comes out on that little like ticker machine? All right. Weather used to come out on the same kind of paper, and it just hasn't updated the system. It just hasn't updated how we display the weather. So we only had 6 characters to use. So they're like, well, we got to display weather or wind over 100 knots somehow.
Oh, I see. Okay, so that makes sense for the wind velocity, but what about wind direction?
Well, I had to give you some kind of identification that there was wind over 100, because if I just gave you a direction, you'd go, oh, that must be 240 at 2 knots.
Oh, I see.
Right?
Okay, I get that.
I mean, the only other and temperature can be high, right? So if I just added 50 to temperature, you'd be like, oh, well, that's odd, but 84 or 74 degrees 84 degrees at 240. I mean, that's toasty. Maybe there's a solar flare going on.
Okay.
right?
Yeah.
I don't know why they designed it that way. That's my ideas on why they designed it that way.
Okay.
I'm happy with your weather resources. You're pretty good on just knowing weather in and of itself. You know the big ones, like how like where a thunderstorm's going to happen, how thunderstorms start, the different stages. So I say you brush up on those little things that we brought up. You are going to be good for your check ride. Do you have any other questions for me?
No, this was a really valuable exercise for me. Thank you.
Yeah.
I got a lot out of it. I appreciate you giving me your time.
Yeah, of
And
course.
I'll let you know how my check ride goes. 12 days.
Of course. So, if you want to take Discord, this isn't just a video conferencing kind of software. If you looked, you saw the rules and role request section on that same spot where you click the little hype kitty to get verified. Once you do go get your private pilot's license, you can come back in there and click the little bird that'll mark you as a pilot in here. But the big one is there's this check ride gouge section in the aviation section. Come tell us how your check ride went. There's like 380 people in this Discord right now. A lot of them are student pilots in the same shoes that you are right now, trying to prepare for their check ride. So come tell us how it went. I also can't make these more accurate if I don't know what the DPs are out there doing.
Okay. That's great.
But also, it doesn't just at the end of this little conference, meeting thing. The questions don't have to end there. If you have any other questions, you can always go to any of these other ones like pilot training, flight training questions, aviation general, ask any questions you want. Anybody that's got a little blue dot next to their name is a CFI. And I've actually verified them. It's not just somebody saying, yep, I'm good, I'm a CFI. I've actually verified them against the Airman Registry. So they are flight instructors. So don't be afraid to ask any other questions.
Okay. And just to clarify, to be able to get into the Discord, there's just like a chat on your channel. And
so you're in the Discord right now. You've got the app, right?
Yes. Mm-hmm.
You got the app on your phone. So if you open up that app, up the top left, you should see a little arrow. And when you tap that arrow, it'll bring you up the list of all the different sections and channels and whatnot that we've got. So if you scroll up to the top, that's just the server stats, like who's online, how many instructors, how many students, how many pilots. Then the next one is just general. This is just talking about anything. There's a whole section on cat pictures, like people showing pictures of their little kitty cats. And then there's one for dogs and memes. And there's the next one is here. I'll just share my screen so that you can see what I'm seeing. Here it is. All right. So on yours, you're going to mainly just be seeing, let's go back to the roles and requests one, right? So you're mainly just going to be seeing this screen right here. Okay. You should see a little arrow up in the top left, and that's going to bring up this menu over here. Okay. This menu all over here is all the different channels. All right. So we have announcements. This is really just where new videos get posted, right? Then if you come down here to general, these are just conversations. Look, somebody's showing off the fact that they just bought a new camera. All right. Then you got cats, dogs, memes, affiliate links. So we've got like private pilot and stuff like that. Then here in the aviation section, you've got aviation general. This is just any and all aviation stuff. Like, look, someone brought up a de Havilland Vampire that got turned into a business jet. Ridiculous. But somebody's also talking about a flight they're planning, asking for advice from anybody. Content sharing, again, if you got any kind of airplane, whatnot, you want to send pictures of. Pilot training section. This is really where you want to ask, any kind of questions you've got associated with whether, private pilot, instrument, as you continue on in your career, or even just how the airlines work. Aviation news. You see any good news? Come drop it here. This is in the check ride gouge section is where you're going to drop, or if you want to, share your check ride experience on like what happened, what went well, what went wrong, what should we have prepared for, what didn't I prepare you for, things like that. And then there's games down here.
Okay.
All right.
Thank you for the tutorial.
Yeah, I know Discord's
I'll
a little.
Share.
Oh, go ahead.
I was going to say, I'll definitely share I'm planning on writing up a gouge. So
Awesome.
come on and share that.
Well, you enjoy the rest of your night. And again, thanks for rescheduling this. I think you scheduled it in the middle of Oshkosh and I just hadn't blocked out my schedule.
Enjoy Oshkosh.
Yeah. Go check on your mom. You enjoy the rest of your night.
Okay. Thank you.
Yep. Bye.
Bye.